Okay, welcome back, everybody. In this section, we're going to be talking about the binomial distribution and how it relates to probabilities. We're going to learn how to compute the probability using the formula. I'm going to show you how to do this by hand, but I'm also going to show you how to do it in Excel because you'll need that for one of your projects in the next couple of weeks. So make sure that you reference this video if you have any trouble with that. And then we'll talk about how to find the mean and standard deviation of a binomial random variable, which is relatively straightforward, as you'll see. The binomial distribution is based on a fixed number of trials and outcomes. Okay? And what we do is we consider for each trial, there is some outcome that is a success and some outcome that is a failure. There's only two that's possible, either success or failure, right? Yes or no, essentially. Okay. The success part is the part that we're interested in. Okay. It's not necessarily a desirable outcome. It's not necessarily a good thing, okay, but it's the one that we're trying to learn about. Okay. A failure is the opposite, okay, whatever the other outcome is. Okay, and in this case, the probability is this is a random event, okay, and the probability of success should be the same at each point. In other words, the probability of a person being chosen should be the same at each point, depending on how many you're choosing. Okay, the probabilities won't change like they did in the last section, right? Well, the probability of each particular event doesn't change. The probabilities change based on the number of successes and failures. Okay, the trials are independent from one another, right? So you're randomly selecting people or you're randomly choosing things, but each choice is separate from the other one. It doesn't depend on the previous one, right? There's no conditional probability here. Everything's separate from one another. Okay, the outcome of one trial does not affect the outcomes of the others. Okay, and in this case, we're going to use that random variable x to represent the number of successes that occur. Okay, and here we're going to use some particular notation, and I'm going to add one of my own just so you guys can see. N is just the number of trials. Okay, X is the number of successes. Okay, I'm just going to add that here. Okay, P is the probability of success. This is the probability of whatever X is. Okay, and then the probability of failure is just 1 minus P. Okay, but you'll sometimes see this written as Q. And I do that sometimes. So I just wanted to point that out. It's just a slightly shorter way. Okay, it is just the opposite probability of P. So let's take a look at this example. Okay, and we're going to kind of start with this example and then talk about how to solve it. Okay. Yeah, our favorite fast food chain is giving away a coupon with every purchase of a meal. You scratch the coupon, reveal your price. 20% of the coupons entitle you to a free hamburger, and the rest of them say, better luck next time. So you got a 20% chance of winning, 80% chance of losing. You go to this restaurant with a group of 10 people, okay, and everybody gets their food. What's the probability that 3 of you win a free hamburger? And before we dive into any of this, think about how many, if there's a 20% chance and 10 of you are eating, how many would you expect to choose, right? How many would you expect would win a free hamburger if 20% of the 10? Right? And then let's kind of see where we go from there. Okay. The probability, here we want to find the probability that 3 win. And so we're not going to exactly do it like I said. I just wanted you to intuitively think about it. We're going to let X be the number of people who win a free hamburger, and we want to find the probability distribution of X. Well, we can determine the probabilities for each of these possible outcomes. Okay. The total number of ways this can happen, okay, is related to the combinations formula that we talked about in the last section, or in the last week, right? So remember that we're not talking about any particular 3 people in order who are going to, win one prize, then win the next prize. They're all, it doesn't matter which 3 win. We're just trying to see if 3 win. So we're dealing with combinations here. Okay, so that's going to be part of this calculation. The other part of the calculation is based on the probabilities. Right? Remember, we multiply probabilities for each independent event in this way. And so the probability of one person choosing, the probability of winning one free hamburger out of one person, an individual out of the 10, getting a free hamburger is 20%. Okay, if 2 of them, well, then they both have that 20% probability. If there are 3, then all 3 have that 20% probability. Okay, and that means that the other 7 all have to have the 0.8%. Right? There's 80% of the time. That's 5. Okay. And so if we multiply all of these, right, we'll get an idea of the probability of this event happening. Okay, but we have to add one little piece to it, right? I want you to kind of see where this comes from. Whoops. It comes from the idea that we talked about. Okay, but it also comes about the combinations formula and the probability raised to these different powers. Right? 3 is the number that we're interested in. That's the number of successes. This power is always the total minus x, minus the number of successes. It's the number of failures. And so that's where these come from. Once again, you can sometimes see this as Q. It makes it a little easier to write. If we want to find the probability that 3 of you win a free hamburger, okay, then the probability of 3 is going to be 10 choose 3. Okay, so this is our combinations formula. Remember, that's just counting. We're going to plug that into a calculator. Okay, or we can use the factorials if we want, but it's easier just to use a calculator. Times the probability of winning a hamburger was 0.2 to the 3rd power. That's how many we want to win, times the probability of not winning to the 7th, right, where those values came from, 10 minus 3. 10 minus 3. And so if we plug all of this into a calculator, let me find this in my calculator real quick. Aha, there it is. We want 10. We're going to choose 3 to win. Again, you want to use combinations here, not permutations. Times 0.2 to the 3rd power. Times 0.8 to the 7th power. And there is a 0.2013, or about a 20% probability that 3 of you will win a free hamburger. Okay. So let's take a look then at another example, I think. Yeah, so let's just practice with this formula a little bit, so you guys can kind of get the hang of it, and using your calculator with it. Again, the combinations value will be different places in the calculator, but I'm also going to show you how to do this in Excel as well. So you can use that too to calculate these values if you need to. Here we want to find the probability of 8 successes in some 20 number of trials. This is the probability of 8. Okay, we're going to have 20. We're going to choose 8 of them. The times the probability of success is 0.7, right, to the 8th power, times the probability of failure is 0.3, 1 minus 0.7, to 20 minus 8 is 12. Okay, and so now we want to just multiply all this stuff out, right? And that'll give us the probability of there being 8 successes in this case. Bear with me while I type this into my calculator again. And what we're going to find is the probability of 7 successes in whatever situation this is. I think this is just a random binomial experiment. 0.3 to the 12th. I'm sorry, I'm still typing in the calculator. 0.00386. Probably call it 39 too if you want. So this is the probability here. Your probabilities should never be greater than 1 or less than 0. So here we're essentially counting the number of ways this could happen and multiplying it times the probability of all of those things happening all at once. And that's where those formulas are coming from. Now here we want to determine the probability for this binomial experiment. We have 8 trials, the probability of success is 0.2, but here we want to find the probability of fewer than 3. So if we want the probability of fewer than 3, well then we need to know the probability of 0. We need to know the probability of 1, and we need to know the probability of 2. We have to calculate all of these in order to get the probability of fewer than 3. Right? Much like we did in the last section, we're just going to add all these probabilities up. Right? It's the probability of 0, 1, or 2. And so times 0.8 to the 8th power. Here we're going to 1. I'm going to plug all this into the calculator at one time, or I might have the answers written down already for you guys. Save me the time of typing this all on the calculator. And then we're going to do 0.2 squared and then 0.8 to the 6th power. Okay, and then here you should get, when you plug this into your calculator, 0.16, call it 78. We'll just do these to 4 decimal places. 0.3355 and 0.2936. And so if we want the probability of, fewer than 3, so 2 or less, we're just going to add all of these up. 0.1678 plus 0.3355 plus 0.2936, 0.7969, or 79.69%. So there's about an 80% chance that you get 3 or less. Here we want to find the probability for, we're given 50 trials. Okay, the probability is 0.03 now, the probability of success. But we want to know what's the probability of 2 or more. Okay, well that, we can't do it the way we did last time because we would have to calculate 48 different variables, right? But again, remember the total probability should equal 1. And so we still only need the probability of 0 and the probability of 1. And then we can subtract those from the total probability. to find 2 or more. Okay, so the probability of 0 in this case, 50 times 0.03 to the 0 power times 0.97 to the 50th power. And then we're going to use 50, choose 1, 0.03 to the first power. And now it's much easier to calculate this twice. For the first one, you should get 0.2180 or 2181, we'll call it. And for the second one, 0.3372. And if we add these two up, 0.2181 plus 3372, 55. And so this is the probability of 1 or of 0 or 1. And so the probability of 2 or more is going to be 1 minus the probability of, well, I mean, you can really do it as 1 minus the probability of 0 minus the probability of 1. It's all the same thing. But we're just going to subtract 1 minus 0.5553, 0.4447. And so again, we can find the probability using the complement, especially if there's a whole bunch of trials. So let's look at a more real life example rather than just randomly chosen numbers. According to a report by the Nielsen Company, 65% of internet searches in May 2010 used the Google search engine. Assume we have a sample of 25 searches. What's the probability that exactly 20 of them used Google? So we're going to randomly sample 25 different searches. Okay, there's a 65% in each case, a 65% chance in each case that they used Google. We want to know what's the probability that exactly 20 of them used Google. That word exactly means we just want the probability of 20. Okay, and in this case, again, we have 25 total. We're going to choose 20 of them. Okay, there's a 65% chance of success. There's a 65% chance of using Google, right? And we want there to be exactly 20 of those. And then a 35% chance it was something else. Okay, and we can put all of that into the calculator again. And you should get 0.0506, or about 5%. So there's about a 5% probability that 20 of those searches would be Google. I think there's one more. Okay, this is always a good one for students. Student takes a multiple choice test that has 10 questions. Each question has 4 choices. You're going to randomly guess each one, right? One of them is correct. Okay, so that means the probability of success, 0.25. Okay, the probability of failure, right? And again, I'll just write it as Q here, 0.75. There are 10 questions. What's the probability that the student guesses 3 out of the 10 right? Right? There are 3 successes. And so again, we're going to do 10 choose 3 times 0.25 to the 3rd power times 0.75 to the 7th power. That should be a 3. And here, this is going to give you, if you put this in your calculator, you should get 120 times 0.25 cubed, 0.75 to the 7th. Okay, and that probability about 25%. Okay, so there's about a 25% chance that you guess 3 of them right out of the 10. Here we are with the same type of question, right? We're going to randomly guess at each answer. The student has to answer 7 or more to pass. Would it be unusual for them to pass? Okay. So there are 10 questions. If they have to get 7 or more correct, then we want the probability of 7 or more. Well, let's look for the probability of 7, 8, 9, and 10. Okay. And so that's 10, 7. I'm going to write all of these out. Here that we get 3 wrong, 7 right. Here then we're going to get 8 right and 2 wrong, and so on. I'm just writing all these out so you guys can see all the different terms here. Obviously, this is a little tedious to write, but here in just a moment, I'm going to show you how to do this in Excel. Oh, and this is getting all 10 of them right. And so you'll see that we can shorten this a bunch if I would be using Excel right now. And so if we get all of these probabilities, this is going to be, and I'm just going to write these to 4 decimal places, 0.0031, 0.0004. Well, maybe I might have to go to 4 decimal places. Or 5, 0.00002. Well, I have to go to a lot more than that. Okay, but we can add all of these up and clearly see that it is not equal to 5%. And so, yes, it would be unusual. There's only a 0.3% chance. This is 0.31% that you can guess 7 of them right. Okay, only a 0.04% chance that you can guess 8 of them right, so on. And so it would be really unusual for you to be able to guess and pass the test. Just like with the random variables we talked about in the last section, right? We can find a mean and a variance and a standard deviation for these particular random variables, okay, for binomial random variables. And they're actually relatively easy to calculate, right? And I implied the first one to you at the very beginning when we talked about how many you'd expect out of 10 people. If there's a 20% chance of winning a hamburger and 10 people, take a shot, if 20% of those 10 people win, that means there's 2 of them, right? 10 times 20%. That's how many you would expect to win, would be about 2. I implied that to you at the beginning, right? And so that's where this mean comes from. Okay, and then the variance and standard deviations are just related to the relationship between P and Q. So let's look at these examples here. Okay, and I'm going to try to show you at least one of these in Excel towards the end, right? So here we reported that 30% of adults in the United States have hypertension. What's the mean number who have hypertension in a sample of 25 adults? Okay, well, the expected value is going to be the number, right? 25 n times p. Okay, and then the probability is 30%. If we multiply those two, if we randomly choose out of 25 people, we expect 30% of them to have hypertension, so that'd be about 7.5. Okay, this part is somewhat intuitive, right, if you think about it. If we want to know the standard deviation, okay, well, let's just go back to the formula so I can show you real quick. We want to first always find the variance, and then from the variance, we'll get the standard deviation. Okay, the variance is just n times p times Q, or 1 minus P. Okay, and so the variance, N times P times 1 minus P. And so that is 25 times 0.3 times 0.7. That will give us the variance, which is 25 times 0.3, 5.25. And then we take the square root to get the standard deviation. Square root of 5.25, 2.2913. Well, let's call it 2.29. And so we'd expect that about 7.5, about 70% or 68%, right? If you think about the empirical rule, plus or minus 1 standard deviation would fall, or be within that range. So you'd expect that you would choose 70% of the time, you'd choose between about 5 and 9 people with hypertension. If we were to randomly sample 25. This is our expected value. And the standard deviation tells us how the expected value will deviate. Now, I believe this last example, we're going to move to Excel, but or actually, I think we could do this a little bit of a different way. But I do want to show you an example in Excel, so I know which one we'll go back to the multiple choice question in just a second. Mendel discovered heredity. He produced plants whose parents contain genes for both green and. His theory states that the offspring of two parents is a probability of 0.75 having green pods. That's what we're interested in. Okay, and 80 such plants are produced. We want to find the expected number of plants that have yellow pods. Well, the expected value, okay, is going to be if we have 80 of them and 75%, I'm sorry, yellow pods is going to be 25%. Sorry, be careful with the words there. So about 25%, so 20, 80 times 0.25 should be 20. We'd expect about 20 of them to be yellow and about 60 of them to be green or whatever the other color was. Yes. And now I think we want to find the variance in the standard deviation for the yellow pods. And so again, the variance is where we want to start first. N times P times 1 minus P, in this case, 80 times the probability of a yellow pod is 25, 0.25. Green pod is 0.75. Notice here that it won't matter because you're just going to multiply them anyway. And so the variance should be 15. And then you take the square root to get the standard deviation. I don't know what the square root of 15 is. 3.87. And so we have our standard deviation, and our variance was 15. So let's go back really quickly. I just want to refresh your memory, and then I will pause briefly. And when I come back, I'll have Excel pulled up, and you can, I'll show you how to do an example. So let's talk about this real quick. This test example, right? Student takes multiple choice test that has 10 questions. Each question has 4 choices, okay? And you're going to randomly guess at each one. And so 25% chance of guessing it right. Okay. 75% chance of getting it wrong. We talked about that before. Okay, so just keep that in your mind. This is the example we're going to talk about. I'm going to pause here, switch over to Excel, and I'll show you how to answer this question using Excel. Okay, so now you should all see Excel. And so let's talk about that, the question, the multiple choice question. So we have 10 questions on a test. Okay? We're going to say X is the number of questions that you guess correctly. Okay? So you could take and guess all of the questions, right? And you could guess 0 of them correctly. Okay? Or you could get 1, 2, 3, so on. Okay? Now, if there are 10 questions, you could type this out. If there are 100 of them, that might take a little bit longer. So I'm going to show you a quick Excel trick. Okay? If you highlight all of your initial data, the list that you have, and then come over here and just grab the corner, you can drag down, and notice it'll pop up a little number beside it. You can drag down till you get to 10 or 18 or whatever number you want to go to, and it'll cut it out for you. That's the first trick. That'll save you a ton of time. And now we want to find the probability of each one of these situations. Okay, remember the probability formula, the combinations based on the total number and the number of successes times the probability of success raised to a power. Okay. So in Excel, if you want to find the combinations value, right, or if you want to find the probability, you're going to type equals. And you can do combin. Okay, when you open the parentheses, it's going to say the number and then the number chosen, right? There's a total number of 10 questions. We're choosing, in this case, 0 of them. Okay, and now for the other pieces, we just multiply times the probability of success. The chance of guessing it right was 0.25. Okay, and then shift 6 will give you the little arrow, and then we're going to raise that to the 0 power times 0.75 raised to the 10th power. And that will, if we just hit enter, give us the probability. So the probability of guessing, you get about a 5% chance of guessing 0 right. Now, we could type that in for every single one. Again, for 10, it's not so bad. But that will take a lot longer. Okay, and unlike before, we can't just click and drag this because it's just going to give you the same thing over and over again. Okay, you have to be a little aware of how you can set up the formula. So I'm going to show you guys another little trick here, and that should be helpful with you. So let's say we want to do we want to know the probability of guessing 1 right. Well, we're going to do the combinations. The total number is 10. That number doesn't change. Okay, but the number chosen does. Okay, but the number chosen, X, is right here. And so we're going to reference it there. Times, there's a 25% chance of guessing it right. Okay, but now we want to raise it to X, right? The power of X. Well, here's X again. So we can just raise it to the power of a 3. Okay, and then there's a 0.75% chance of getting it wrong. And now we have to raise it to the power of 10 minus 1, right? Or 10, and I would use a parentheses here. It's not necessary. 10 minus a3. So I think that parentheses is necessary. If you don't use that, it'll do something different. Okay, then we just close the parentheses there. Now, there's our probability of guessing 1 correctly. But the good part about this is because we built in the Excel links to this cell, now we can just click and drag. And we'll get all of them, including those really small ones at the end, including the 4 that we calculated before. And so now we could find the expected value using these. We can show that we have all the probabilities. If we add up all of the probabilities, we can see that they're all equal to 1. Okay. We can show We could find the probability of choosing 3, which was one of the other problems we had before, or the probability of just choosing 4 or 5. And so this formula is generally easy to work through in Excel. Okay, you just got to be aware of how you reference these values. I would suggest making a table like this for every problem that you're working on in that activity. In fact, that's part of the requirements is to make a table like this. Hopefully this helps with some of the Excel stuff. You guys, if you have any questions or anything this week, please let me know. Next week, you will have a test. So there will not be any new videos next week, but we will pick up again in a couple of weeks talking about how all of the binomial probabilities and things then link to other variables that we measure that are not discrete, continuous variables. If you guys have any questions, please let me know, and I will talk to you guys soon.